In case there's anybody who's really not familiar with WIPP, we're America's only deep geologic repository, and we take transuranic waste and permanently dispose of it. We do have a proven track record for safe and compliant transportation and placement of transuranic waste. We were approved by Congress under the Land Withdrawal Act to dispose of up to 175,564 cubic meters of transuranic waste, or roughly 6.2 million cubic feet of waste. All of the waste that we receive goes through a certification process where we're able to validate that it meets our waste acceptance criteria. And we do strive to have open and transparent communication with all of our stakeholders, whether they're locally in the Carlsbad community or elsewhere within New Mexico, or even in the communities that the department's generator sites are located at. Next slide, please. So again, the purpose of our repository is to take defense-related transuranic waste, and that is material that's generated from either research activities or production of nuclear weapons, and that material is placed in the WIPP underground. Next slide. And so what is transuranic waste? So it's essentially material that is on the periodic chart above uranium, and you can see the different isotopes, primarily plutonium, but there's also neptunium and americium wastes as well. And we do receive waste that is a combination of both radioactive and various chemical constituents. We do have a requirement that the concentrations of that material has to be greater than 100 nanocuries per gram from the transuranic elements that are contained in the waste. Next slide, please. We also, as I mentioned, go through a characterization or certification process. So after the waste is generated and placed in a container, we also take all the historical information that we have on that particular waste stream, evaluate it, make sure that it meets all of our criteria, that we have sufficient characterization information available from it to be able to place it in the repository. We also do radiography or visual inspection of the visual examination of the wastes. We also do non-destructive assay, and then we do flame gas analysis, so essentially looking for hydrogen in the headspace of any of the containers of waste. As we go through that arduous process and we're successful in each of those steps, the waste is considered to be properly characterized, and we go through the formal paperwork to certify that package before it comes to us. Next slide, please. So I'd like to point out here, this is just another look at the process where waste comes from the generator sites to the repository at WIPP. I would point out that we have, we're showing WIPP on the left-hand side of that slide, which normally that's where you start reading from. Secretary Kenny has emphasized several times to us that all roads start at WIPP and not lead to WIPP. And so as part of our philosophy of trying to work with our regulatory agencies as well as stakeholders, we're trying to illustrate that yes, we recognize that ultimately we're providing a service to the generators, and we need to make sure that we represent the interests of New Mexico as well as the department's mission needs as well. As the waste is generated at the generator sites, I did talk about some of the work that the generator sites do to get those container's ready for us, then we enter it through the formal certification process, which is the AK, some of the data verification, like the radiography, flam gas, NDA work that we do. And we also do annual audits of the generator sites where we ensure that the programs that are in place meet the criteria that are outlined by either US EPA or in the WIPP that comes out of the permit. And we also have requirements associated with transportation. The packages that we use are certified by the NRC, have very stringent requirements associated with them. And so when we load those packages into those type B shipping containers, we have to make sure that we're compliant on that front as well. All of that occurs before we put any waste on the road, and then it arrives at WIPP for receipt inspection and emplacement. Next slide, please. So you'll hear us talk about different types of transuranic waste. Contact handled is exactly that. It's something where you can touch the side of the container. You're really not receiving any kind of dose from that material. It doesn't need any shielding, and that's about 96% of the waste that we dispose at the repository. Go ahead to the next slide. Remote handled waste, though, it does emit more penetrating radiation, and that requires additional handling requirements. And so when we transport that material, it goes into a shielded cask. And then when we handle it on site, it also is shielded through the various stages of the process for emplacement. And that accounts for roughly 4% of the waste that we dispose of in the repository. Next slide. So, one of the questions, we get asked is, so why Carlsbad? Why is WIPP located where it's at? And really, it's a function of the salt. And, it's a very stable geology. We have a half a mile of salt that is fantastic to be able to allow it to close and encapsulate and isolate that waste. It's relatively easy to mine. So from an operational perspective, it allows us to maintain the repository. And of course, we have some really strong community support in the Carlsbad area. They support the WIPP mission, and we are very much an integral part of that local community. Next slide, please. So here's a video of some salt creek closure when I was talking about why we look at why we placed WIPP where it's at. The plastic nature of the salt allows it to encapsulate and isolate the waste. So certainly WIPP plays a national role, not just supporting sites in New Mexico, which include Los Alamos, Sandia, as well as the Lovelace Respiratory Research Institute, where we were able to move material off-site. We've supported the cleanup successfully of 22 DOE sites across the country and are currently working to support the cleanup of the other generator sites that remain. Next slide, please. So when we take a look at how we accomplish that mission, we do ship waste across the country. These are on designated routes. All of those shipments are pre-approved routes. They do go through New Mexico to arrive safely at WIPP. And I would point out that our transportation program is recognized as one of the safest in the world. So when we take a look at the, I'll say, robust nature of our transportation program and all the barriers that we have in place to ensure the material arrives safely at WIPP, I'll start off with the payload containers, or the waste drums or boxes that the transuranic waste is placed in. Those are all certified Type A packages, which means they have to undergo a series of tests, including a water test, a free fall test, stacking test, penetration tests, all to make sure that they are able to contain the material. Once the waste is put in those containers and they go through the certification process, they are then overpacked in Type B packages, which are certified by the NRC. Go ahead to the next slide, please. So these, here's an illustration of what a Type B package looks like. In this particular case, you can see the TruePack 2. They are much more robust than the Type A. And as I said, we go through a series of analyses and tests that are then independently reviewed by the NRC to withstand a predetermined list of hypothetical accident conditions without any loss of containment. These include a 30-foot drop test onto a flat unyielding surface, a 40-inch drop onto a 6-inch diameter steel rod at least 8 inches long, a fire at 1475 degrees for 30 minutes, and then immersion in water with an external pressure equivalency of 50 feet. And so those are pretty substantive tests that we undergo to ensure that the packages that we use on the road are robust enough to withstand any of the conditions that might be realized during an accident en route to WIPP. Next slide, please. We do have 4 different types of Type B transportation packages. So the half pack, TruePack, and TruePack 3 are primarily used for contact handled waste. The RH72B is specifically designed with additional shielding to handle remote handled waste. Next slide, please. Not only do we invest in the packaging, we also invest in the drivers. We have the most stringent requirements for drivers that are transporting the true waste to WIPP. Not only do they have to have at least 325,000 miles of driving time within the last 5 years, they must also not have any repeated chargeable incidents or moving violations over their career, and must not have been charged with a moving violation in a commercial vehicle within the last 5 years, in addition to background checks that these drivers perform. Next slide, please. In addition to the packages and then the driver qualifications that we have, there are a number of additional requirements. Each of these vehicles undergoes a level 6 inspection, has to be 100% defect free before it's released from the site. Those are typically done by the local authorities in the host state for the generator site. We do have 2 drivers per shipment. Drivers will stop at the first 50 miles and do a vehicle inspection, and then they will do an inspection every 3 hours or 150 miles to make sure that there's no issues that develop en route. Speed is restricted to 65 miles per hour, and we cancel or divert shipments to alternate routes during weather warnings. Additionally, there are certain states that have requested to be able to perform additional inspections en route. So Colorado and New Mexico being those 2 states. And so those are performed whenever vehicles are entering or exiting their facilities. Next slide, please. Sorry, their states. Not only that, but we also do satellite tracking of all of our shipments. Those are updated every 5 minutes. That is actually information that is also available to the various states and tribal nations along the corridors, where they're able to have real-time monitoring of our shipments, in addition to the monitoring that we do independently in the Carlsbad area. And we have an ability to constantly communicate, including backup systems between the trucks and WIPP's central monitoring room. Next slide, please. And finally, even though we have this robust set of controls in place to ensure safe shipment of the transuranic waste, we also invest in community training. And so along the WIPP routes where we're transporting the transuranic waste, we provide funding and training and equipment to those local communities to make sure that they have the skills and capabilities necessary to support the shipments in the event that there's an issue or an accident along the route. Next slide, please. So let me just talk a little bit about some of the accomplishments that we've had. So far in fiscal year 22, we have made 158 shipments, and that equates to just over 170,000 loaded miles in this fiscal year. To date, since opening in 1999, we have received over 13,000 shipments. I believe we met that milestone last November. And then we have traveled over 15 million miles of loaded waste. We've emplaced over 265,000 contact handled waste containers and emplaced 775 remote handled waste canisters at WIPP. Next slide, please. So let me talk a little bit about some of our priorities for fiscal year 22. We're trying to return to a shipping rate of 10 to 12 shipments per week. This is about half to a third of some of the shipping rates that occurred in the early to mid 2000s. And so we're in progress on that. Sean and his team are working to be able to do that. That is going to allow us to continue to meet the needs of generator sites across the country, including maintaining a steady stream of shipments out of Los Alamos. We'll be talking a little bit later on two of our capital asset projects, the safety significant confinement ventilation system, which is a huge filtered airflow system, ventilation system, and then also a new utility shaft, which will allow us to have a separate air circuit in the underground so that we can operate more efficiently. And we have seen major progress on those two projects. We also recently received NRC approval for an additional set of shielded container assemblies. These are shielded packages that will allow small containers of remote handled waste to be overpacked and then handled as contact handled waste. So this is an operational efficiency for us and allows us to meet the needs of the various generator sites. And in fact, one of the sites that we're looking to use some of these new shielded containers assemblies is located in Albuquerque. The Sandia National Lab has got an inventory of remote handled waste that we're interested in moving and closing out that particular facility. We continue to prioritize Los Alamos National Lab EM related shipments, as well as the shipments out of Idaho. We certainly have the capacity to be able to support both projects. We have begun mining drifts to the west. This was important to us as it allows us to prepare for waste emplacement past the current panels that we are working in. Sean will talk a little bit in more detail about that as we move forward. And we haven't shipped any remote handled waste since the 2014 timeframe, other than a small quantity in some shielded containers. And so we're in the process of reestablishing that capability. And so one of the first step is to work on some of the handling equipment in the RH bay out at the facility. And finally, we anticipate transition to the new M&O operator sometime this fiscal year. Go ahead to the next slide, please. So where are we right now? So right now we have completed emplacement in panels 1 through 6. So you can see them there on the screen. And we're finishing up emplacement in panel 7. We're about halfway through the final room, which is room 1. And once we get out of panel 7, we will move towards panel 8 for waste emplacement. Approximately 40% of the WIPP Land Withdrawal Act limit for transuranic waste has been placed to date. Okay, and so we will need some additional panels to support the continued emplacement of transuranic waste. Some of the panels that we have planned include replacement panels 11 and 12. We lost some space in the underground as a result of some of the initial operations. You can see the blank space in room 1. There was a panel 9, which is reflected in that red hatched area to the right of the screen. That's an area that is prohibited for access due to ground controls, and so we're not able to use that portion of the repository. And then also there's some rooms in panel 7 as well that were not able to be used for waste emplacement either. So panels 11 and 12 are essentially replacement panels. Now, there is a need for some additional panels, and we'll be looking at that during the NEPA process. That's really a result of some packing inefficiencies to be able to dispose of the full volume authorized in the Land Withdrawal Act. Go ahead to the next slide, please. Here's a little graphic on some of the shipments. You can see the actual shipments that we had in 2021 and where we are today, and then what our target is for the end of the fiscal year. So we're trying to get to just shy of 300 shipments this year. And so I think Sean and his team have got that challenge cut out for themselves and are working through that as best they can. Next slide, please. Here you can see some information with regard to historic shipments and where we're really looking to go in the future. You can see certain years in the past, the repository or WIPP has received well over 1,000 shipments in 1 year. And so, but when we take a look at the 20-year average from when we opened in 1999 all the way through 2019, that average is just shy of 600 shipments per year. And as we are coming out of COVID and are resuming our waste shipments, we're continuing to ramp up, and we'll be targeting somewhere between 680 to 800 shipments a year. So that equates to roughly either 17 or 20 shipments per week. And a lot of that will be driven by our ability to safely demonstrate the rate of emplacement that we would like to have, as well as getting the airflow into the underground, which is very important for us to be able to maintain the safety of the workforce. Go ahead to the next slide, please. Talk a little bit about the Los Alamos shipments. So we're take a look at what we shipped last year. We had 56 shipments from Los Alamos, and this year we're looking at roughly 70 shipments. So we do have a big increase. And we do anticipate continuing to increase those shipments from Los Alamos as waste is run through the certification process. Right now, when we take a look at the inventory, we have essentially somewhere between 1 to 5 shipments available at any given time, and we do make 2 shipments per week. So there is a little bit of an ebb and flow of waste availability, and by managing the waste to 2 shipments per week, we're able to go ahead and maintain a minimal inventory out at the facility. We have also done some demonstrations where we've had a couple weeks where we shipped at 3 per week, but the end result ends up being that we're only able to have maybe 1 shipment about 2 weeks later. And so we pretty quickly get the material that finishes the certification process successfully onto our trucks and into the repository. Go to the next slide, please. One of the things that we've taken the initiative to do is really see if there are improvements in the processing of the waste through the certification process. It's not WIPP's responsibility to actually do the waste generation and initial characterization. That really is the generator site's responsibility. But once it enters into our program requirements, we have very robust set of criteria and have to work to make sure that material is successfully streamlined and run through that process. What we found is there's a lot of opportunities to be able to streamline and get more efficient, not only processing of the waste through the certification process, but also being able to ship it. One of the things that we've been successful in doing is being able to mingle EM and NNSA waste shipments, not only shipping out of the same facility, but being able to mingle those packages in the same payload or in the same troop pack too. That allows us to minimize the amount of dunnage or empty containers that we put into the repository. It also allows us to more effectively pair containers together to get a larger volume of containers into WIPP at a faster rate. And so we're continuing to work with our counterparts on both the EM and NSA side of the house up at Los Alamos to drive some of those process-related efficiencies so that we can continue to increase shipments out of Los Alamos. Next slide, please. Again, this is just another slide on some of the efficiencies that we're working with Los Alamos, as well as other generator sites as well. Okay, next slide, please. I'll just chat a little bit having to do with the dilute and dispose process. I know this is a topic that has got a lot of interest in New Mexico. And so, there is a volume of plutonium that has been declared excess by the department. That process does go through a formal NEPA evaluation. And so that process results in material coming to us from Savannah River. So, that material is essentially blending plutonium oxide with a multi-component adulterant. That material is packaged in little cans and then loaded into some pipe overpacks, which are essentially a 55-gallon drum with a pipe in the center of it to hold those cans. And once that material has gone through the downblending process, then it becomes part of the true waste program, so to speak. And we have disposed of some similar wastes in the past. particularly some of the Rocky Flats materials back when they were shipping to us in the early 2000s. Go to the next slide, please. So here you can see from this slide, I'll call it the general process at Savannah River, where plutonium oxide is blended with the adulterant in these blend can kits. And so they're then packaged, blended, and closed, and then put into these ROCs, which is a robust outer container that is then loaded into these CCOs, criticality controlled overpacks for disposal at WIPP. You can see that the WIPP process, it really is, once the waste is loaded into those CCOs, that's when it enters the certified program. Now, obviously, we need to make sure that some of the upstream related activities are looked at by WIPP. We make sure that the historical data that's available to us and that the process that's identified to generate these materials provides information that's accurate for us. So when we develop our acceptable knowledge packages and we're going through the visual examination processes, that we have a high degree of confidence that what we're getting is what it was advertised to be. So again, in this particular case, as with all the generator sites, our process really, our formal process really starts once the material enters the certification program and after it's been generated. Next slide, please. So there is a volume of material that has been authorized for DOE, or by DOE for disposal. We still have to go through some of the processes that are laid out in the permit having to do with audits of the new waste stream. And that process is ongoing. There are some additional volumes of surplus plutonium that are being evaluated for disposal at WIPP. As I indicated before, they go through a NEPA process, and then NSA's point of contact for that is Mr. Harris Walker. So any questions pertaining to the upstream activities from WIPP can be directed to Mr. Walker. And he will make sure either your questions are answered or will point you in the right direction and give you a specific contact within NSA regarding those programmatic aspects. Go to the next slide, please. And so I guess I'm going to turn it over to Sean to get into some more detail on the operational activities going on out at the site.
Thank you, Reinhard. I'll pull this closer. I know some people had a hard time hearing. Nodding at me. If you continue to have a hard time hearing, just put me upside the head or something. Talk really loud. Thank you for coming out and your interest in WIPP. Honestly, this is a project that is near and dear to my heart. I was born and raised in Carlsbad, lived there my entire life, raising my family of 5 there. And so it's really my pleasure to be able to work at WIPP and to be able to support this mission, also to support our state. As lifelong residents of New Mexico, my family's been in New Mexico for well over 100 years, and we like to believe that we're pretty integral to the community down there in Carlsbad. Reinhard talked a lot about some programmatic aspects that are going on out at the site, and I'm going to focus more on some of the process or the status of some of the changes that we're making, specifically the capital projects, which are significant investments into future and into the WIPP site. So if we can go to the next slide. I would like to start off by talking about where we were at. I know Reinhard talked about this a little bit in one of his earlier slides, but here's a zoomed in picture of panel 7. And for those of you who aren't steeped in WIPP and don't speak the language, I know we talk in a lot of acronyms and we talk in a lot of jargon, and I'll do my best not to do that today. And I'll try to walk through that. We talk about panels. It's just the term we use for disposal space is panels. Each panel consists of 7 rooms. We are actually in panel 7 right now and placing in room 1. And as you can see on the diagram, we start at the back in room 7 and we work our way forward towards room 1. This image, which shows the waste in the gray, the simulated 55-gallon drums, and the figure is a few weeks old. We're actually past that now. We anticipate we will be completing emplacement in panel 7 towards the end of August, maybe early September, but late summer really is when we anticipate to be finishing off emplacement in panel 7, which will then allow us to go into panel 8. And we will, before we do that, we will close panel 7 as required by our permit. We'll go to the next slide. So here's an image of panel 8, and I know some of you have, and I'm just really curious, how many people have been to the WIPP site previously in the past? Okay, so this might look familiar to you. This is typically what a waste disposal room looks like. It's nice and square. The things at the top are what we call roof bolts. They go into the salt to make it secure. That's part of our ground control program. And what that means is we are embedded salt. So there's different layers of salt that constitute the WIPP site. And we bolt into the next solid layer so that we can maintain solid ground and structure, similar to the way that the potash mines do in southeastern New Mexico as well. It's a very typical method of ground control to ensure stability of the ground while you are in that area. So whenever you see a picture like this and you see the bolts up on top and on the sides, that's what it is. It's to help us with the ground control perspective. Salt, as Reinhard talked about, and as the image showed you, that the video showed you, does move in and close in on the waste over time. And that's just Mother Nature doing its job. And our job is to keep it open until we can put the waste in, so we have to do some ground control measures. Moving towards panel 8 is going to help us significantly with ground control measures that we are battling right now on panel 7. Panel 7, we've been placing waste in since 2013, and we have a number of ground control challenges in panel 7 on a daily occurrence. We have a routine group of individuals who go in and do ground control every single day, making sure that we maintain a safety factor of more than 1.5 in every area in the underground so that people can be safe while they're in there working. That is our number one priority. And whenever we moved to panel 8, the geology actually allowed us to go to the next layer that I was just talking about with the layers of salt. And it was very fortuitous for us from a ground control perspective, because now we have a very thick, solid base for which we can bolt into. It allows us to have a very good ground control presence in panel 8. That'll help us in a number of ways moving forward once we're out of panel 7. Next slide, please. Some of the goals we have for the fiscal year 22 are outlined up there. And really what I would like to talk to you about is how they're not colored. So follow me, please. I'll try to talk through this. I don't have a pointer that works on the screen. But the panels 11 and 12 that you can see up there, we are working right now on the drifts that run from the top to the bottom of your screen. The 3 drifts that we are drilling or mining right now are the southernmost drifts. So in other words, the drifts that are closest towards panel 11 and 12 were on the left side of your screen. That is the progress we are making right now in mining towards the west drifts. So when Reinhard mentioned mining towards the west, that is what he was referencing earlier. And our goal this year is to get about 40% through that. That's a long ways in terms of linear feet. It's 15,000 linear feet to be mined in the 3 drifts that we're going to be doing, as well as the crosscut. Those are the drifts that go, the shorter drifts that run side to side from one long drift to the next. Those help us with transportation of vehicles in those areas, and also help us from a ventilation perspective in those areas. So we want to keep those going. The mining of the access drifts right now is projected to be completed around April of 2024. Mining of panel 11 is projected to be completed around March of 2025 and ready for waste emplacement in November of 2025. And that there's a gap there from March to November because we take a period of time to do the ground control in that panel to make sure that we have all of the components necessary from a monitoring, electricity, lighting perspectives, and to ensure, and we have to certify it with the state. So that's what takes that time from March to November. Typically, when we are operating at the shipping rates that Reinhard spoke to earlier, in the 17 to 20 shipments per week, it takes roughly 2.5 years to fill a panel of waste. And that's why you see the timeline that you do right now on the screen, going from panels 11 to panel 12. It's about 2.5 years until it's ready. Next slide, please. Reinhard mentioned additional panels beyond 11 and 12. Panels 11 and 12 are the replacement panels for areas that we've lost already in the underground as a result of some inefficiencies in ground control situations. Prior to being able to do anything with the additional panels beyond 11 and 12, we will have to go through a National Environmental Policy Act, a NEPA, proposed action. And there's a number of steps that are included in any NEPA action that takes place. Some of those steps include an analysis of impacts. That means impacts of what it means for the excavation to occur, what taking additional salt out of that area will do to the environment. We have to look at reasonable alternatives to the WIPP facility. What reasonable alternatives are there? How would those be impactful to the environment? Which is the best moving forward? We evaluate the resources necessary to perform the work. And then finally, it needs to align with the vision and strategic mission of WIPP while all encompassing the Land Withdrawal Act, because that is our governing document that we operate to. Next slide, please. I'm going to switch over to the projects, the two capital projects that we have going on right now. And these are the significant investments that we are making into WIPP for the future. And so the Safety Significant Confinement Ventilation System, it's one of those really long acronyms that I mentioned earlier. It is a mouthful, so we generally refer to it as the SSCVS, which is also a mouthful for an acronym, but that's where we're at. I don't know who named it. I have no idea who chose that, but I wish we could go back and redo it. The SSCVS is going to allow us to generate more filtered air in the underground. Prior to 2014, we operated at roughly 425,000 cubic feet per minute of air in the underground. After 2014, whenever we went to fully filtered, that dropped to 60,000, so 1/7 the airflow in the underground. Today, we have increased that in it ranges depending upon the ventilation setup and where we are doing on that given day, but it's anywhere from 130 to about 180,000 cubic feet per minute. This new system, the SSCVS, when combined with the utility shaft, will allow us to increase that airflow to 540,000 cubic feet per minute, all filtered. So that'll help us from an ability to perform work effectively and efficiently, but most importantly, it'll help us from a worker safety standpoint, because we will have plenty of air to do any of the activities that we need to in the underground without worrying about or having an issue with the particulate and having to rein back some of those activities in a means to control the diesel particulate in that area. And we have made, thank you. Yeah, go ahead and go to the next one. So this project is primarily comprised of two different buildings that I'm going to talk about and show a lot of pictures of. The salt reduction building, which is at the top left of the figure that you see, is almost 25,000 cubic feet. And the building at the bottom is the new filter building. Over to the left, you can see where the ductwork will be pulling air out of the existing exhaust shaft. That ductwork then moves from west to east, and there is a Y there where it will most commonly go into the salt reduction building. The idea of the salt reduction building is it has what we call dedusting fans. It'll pull the air in that is laden with salt and take the salt out of the air. It'll go out of the salt reduction building, and then it will enter into the new filter building, which has 22 HEPA filters and 6 different 1,000 horsepower fans that will pull that air through and out the exhaust stack. We would prefer the air to go through the salt reduction building first, because we want to get as much salt out of the air as possible before it gets to the HEPA filters to help us from a maintenance and a cost perspective moving forward for years to come. Next slide, please. So looking at the salt reduction building, where we are at today, there has been a lot of work accomplished. The construction of the interior walls is complete. The interior painting is completed. Almost all of the electrical is completed. You guys, what is in that picture, the main picture, the bigger picture, are the salt reduction units that has the plywood there at the end. Those are 4 of the salt reduction units. All 6 have been in place now. This picture is a little bit dated. Up there in the blowout picture in the top left are the turbo booster fans that hook up to the salt reduction units. All of those have been in place as well. Next slide, please. So for some of our goals in fiscal year 22, you can see them on the chart or on the slide, and the ones with the green check mark next to them are ones that we have completed to date. We're close to the electrical, we just aren't there yet. And on the fans, we're not there yet as well, but we expect to be there in the next few weeks. But this is a blown up picture or zoomed in picture of that previous picture that you saw, where you can kind of see just how big these dedusters are relative to the individuals who are up there working on them. They're significant pieces of equipment that are going to pull a lot of salt out of the air so that it doesn't clog up those HEPA filters in the new filter building. Thank you. Here's a few different pictures. I'll try to walk you through them. Right, the biggest picture on the left, you are looking from the east to the west. That circular hole in the wall there is looking towards the WIPP site. That is where the air will come out of the exhaust and into the building from that position. There's ductwork. This is an older picture as well. There's actually all the ductwork is up there now, and the air will come through into that hole, into the ductwork, and through the dedusting fans, and ultimately through the booster fans, which are up higher in the facility, and connect to the top right picture, where you can see kind of the bottom half circle where those connect to the ductwork. The bottom right picture is where the ductwork leaves the building. That's looking west to east. It'll go out from the salt reduction building towards the new filter building in that ductwork right there. Next slide, please. So the new filter building, the other large component of the SSCVS, and just, I don't know how many people know or have had many experiences with construction, especially concrete construction, but there is a lot of concrete in these two facilities. It's about 8,000 cubic yards of concrete that has either been poured or precast and placed. It's a pretty amazing process to watch. The contractor who is performing this work for us is the industrial company. They are a subsidiary of Kiewit, and we are extremely pleased with the progress they are making. They're doing just a very good job, and we're very happy with them. On the new filter building, listed on the slide are some of the accomplishments that have been accomplished thus far. All 6 fans have been fabricated, the 6 different 1,000 horsepower fans. One of the fans is actually on site. The second fan we expect to be on site in a few weeks. The other 4 fans still need to be painted. They'll be painted and they'll finish off all of their quality assurance documentation prior to coming to the site as well. We're making good progress on the new filter building. We have a couple more pictures to show you on the next slide. Now, this is the top where they're doing an elevated pour of concrete. Like I said, there's a lot of concrete in these buildings, and we've completed all of the shear walls that are going to be necessary. We've completed all the precast roof panels. Some of the shear walls, now we just need to go install them. We need to complete the interior painting and also finish off the fire protection system. Next slide, please. Here's an additional couple pictures of the new filter building. This is the picture on the left is from the southeastern portion of the facility looking to the west, the northwest. For those of you who have been on site, and quite a few of you raised your hands, that brown building that you see to the very left where it's cutting it off is the waste handling bay right now. So to kind of give you some perspective about where this building is in the facility. To the right, the picture on the right is actually where the fans are going to go into the squares there, where the fans will blow into the plenum and up through and ultimately out the exhaust stack, which you can see the exhaust, where the exhaust is going to come out of the new filter building on the picture on the left. That is the circular hole in the concrete there at the top. Next slide, please. So the SSCVS is a tremendous project that is going to complete our ventilation system when it's combined with the utility shaft. Utility shaft is a new shaft that will be to the west of the current facility that's going to go down to the horizon in which we dispose of waste at, which is 2,150 feet below the surface. Next slide, please. So this is where I really wish I had a laser pointers, but I'll do my best. So the 3D figure that you see here is a future representation of WIPP. The blue lines that are kind of hard to see if you don't have it blown up and if you're not really close are the different shafts that will exist. The one on the far right of the figure is the current exhaust shaft. The one next to that is the waste shaft, the salt shaft, the current air intake shaft, and lastly, over to the left is the utility shaft that we are sinking in the project that I'm talking about right now. Next slide, please. So the utility shaft, like I said, when it's combined with the SSCVS, will provide our final ventilation system that we need to move forward into the future. What I mean by that is we're going to have 2 circuits of air. Today we are operating with 2 circuits of air, one with negative pressure What that is we have one circuit of error that is focused on the maintenance and the mining portion of the underground. And then we have a negative circuit of error that is focused on anything dealing with the waste and waste disposal, so that we can ensure that the air is always flowing towards the negative side and out through the HEPA filters. Part of this project includes 2 fans that are going to go on the plenum that's shown on the figure here. Those fans are 500,000 cubic feet. They will push 500,000 cubic feet of air per minute into the facility and allow us to have those 2 circuits of air. It's going to allow us to utilize the facility more efficiently, and will help from an operations and safety perspective. Over on the right, you see some of the progress that we've made with the utility shaft this year. The actual sinking of the shaft was halted back in the fall of 2020 at the height of COVID, and we were fortunate enough to resume this past June, almost a month ago today. And we've completed the procurements that we need, and we're ready to get going in a bunch of different ways. One of the main projects that has been completed recently was conversion of the air intake shaft to an exhaust shaft. It'll have a dual function depending upon the mode of ventilation that we're in. We put a bulkhead in there, kind of like a louver in your house, to help control the way the air flows, which is really the way you control the air in the underground, is with the use of bulkheads. So the same technique was used for the air intake shaft. Next slide, please. Here's some pictures of the utility shaft. The picture on the left is from what we call the Galloway. It is the device that does the sinking of the shaft. It pulls the muck out from the shaft, the material that comes up from the shaft where it is being drilled down. On the right is the head frame, and you can see 2 chutes there, the 2 black chutes that look like they will pour out the debris from sinking the shaft, and then we take it and dispose of it in our salt pile. Next slide, please. Oh, I guess that was the last slide. I hope that was, you guys could follow me without any laser pointer. I do apologize for that, and I will apologize again for the acronyms. We actually have a book of acronyms. It's kind of a sad thing, but we have a book of acronyms at WIPP that we have to follow because there are so many of them. So we do our best not to speak in that lingo, and hopefully you were able to follow my discussion today. But at this time, be happy to answer any questions that you have.
Right, so if you have questions, if you want to hold up your cards, we can collect those. No, ma'am, I'm sorry, I'm going to have to ask you to sit down, please. Thank you. All right, so we went a little long, as often happens when you have folks that are excited about their work. They tend to carry on a little long. Bobby, looks like we have a couple more right over here. Yes, ma'am, I'm sorry. I'm going to need you to... She will have an opportunity to speak with DOE in the next part of the meeting shortly. So, okay, ma'am, I'm going to have to ask you to sit down, please, or we're not going to be able to have time for the questions. So, say again, I'm sorry. If she would like to submit a statement, we can take it with the questions, and we can post it on the. But that's how. Ma'am, that's not how we're. Ma'am, please. Ma'am. Are you afraid of us? I'm not afraid of you at all. I'm following directions for the meeting as was laid out. So. And we appreciate her being here and you being here as well. But we're going to follow. No, ma'am. No, ma'am. All right. So we can either take 15 minutes and address some questions that you guys have submitted, or since we're at 6:30 time limit, which this was laid out, we can move forward to the one-on-ones next door. But I think that's. Sir, please. So let's take just a few minutes and let's look at some of these questions. There were a lot of questions that seemed to be, Reinhard, Sean, seemed to cover a lot of the same ground and created some confusion. So we wanted to make sure you guys got a chance to address those. So these come from a combination of the chat and submitted tonight. So there are questions about the, when WIPP was first initiated, it was lined up to go through 2024. And now there appears to be an extension on that. Can you talk a little bit about how that happened and what provides the regulatory statements that allow that to take place?
Sure. The Land Withdrawal Act, as we talked about, the Land Withdrawal Act defines the volume of waste that the WIPP repository can receive. And as I indicated, that's roughly 6.2 million cubic feet, or approximately 40% of the way through that particular volume. And so the intent of the Land Withdrawal Act was to allow WIPP to operate and complete that entire mission.
Okay. So follow-up question to that is, so what happened? The intent was to be finished by 2024, be able to close the site. Why the extensions?
So certainly when you take a look at the accident in the 2014 timeframe, there was some operational delays that had a significant impact on the amount of waste that could be in place. Additionally, there were operational inefficiencies. Certain waste volumes were not ready when originally anticipated, and we're continuing to support the overall national security as well as environmental cleanup missions.
Okay. So there were a handful of questions about geologic and seismic concerns in the area with potash mining, with fracking and oil industry. What are some of the safeguards? How do we know that the WIPP facility is stable and with
so
those
some
issues?
of the original analyses that were completed back in the 70s and 80s identified that area is very geologically stable. That's one of the reasons WIPP was located where it was at. And as we take a look at some of the oil industry activities in the southeastern portion of New Mexico, we do look and monitor for seismic conditions as a routine part of our operational activities. As a result of that, we're able to show that we're not seeing any impact to the stability of the repository itself.
Okay. So there were questions about generator sites, specifically. What were the generator sites? Where are they? And so we'll start with that.
So there's a very large list of generator sites back in the day. I think there was 22 that completed their original cleanup mission. They're located all across the country. We have them in California. Rocky Flats was in Colorado. We have facilities that were up in the New England states, Savannah River, Oak Ridge, Idaho, and of course, our home state of New Mexico. We do have roughly half a dozen sites or so that are left. Specifically, we've got waste at Sandia, Los Alamos, Idaho, Savannah River, Oak Ridge. We have small quantities of waste at Argonne National Laboratory, small quantities of waste at Livermore, and there is a volume of waste up at Hanford that we anticipate will resume processing and shipping for emplacement of WIPP late in this decade.
Cool. So what type of communication do you guys do on a regular basis with the generator sites?
So there's a variety of, say, meetings with the generator sites to take a look at the waste volume inventories they have, so we're able to plan our resources appropriately. Additionally, the M&O contractor, NWP, they have certification teams that are located at the bulk of the generator sites, and they interact on a daily basis with our folks to make sure the waste is gone through the certification process correctly. They also have the day-to-day meetings with the generator sites as they're working to get the waste into their operational areas at those facilities so they can be certified. Uh, I think additionally, we also have what we'll call target teams, where we try to work with the various generator sites to identify operational efficiencies that we can implement as we move forward.
Okay. There were a handful, actually there were lots of questions about transportation from the generator sites through the transportation routes this way. So let's start with a couple of those, okay? Who bears the liability for radioactive waste spills during transportation?
Federal government would.
Okay. What kind of communication do you do with the transportation route in states?
So there's quite a bit of communication with the states as well as the tribal nations. We publish our shipping schedules with the state agencies so that they know what shipments are either planned or en route, so they can ensure their resources are available to perform the inspections as appropriate, whether at the generator sites or, as I indicated, Colorado and New Mexico do inspections entering and exiting those states as well. And so additionally, as I indicated in our discussion, we have satellite tracking of our systems. That is real-time information. It's updated every 5 minutes. All the various impacted states and tribal nations have access to that information real time.
So an interesting question I've never seen before. The actual shipping containers, is there a warranty on those? Is there any, what if the container itself fails?
Yeah, so those containers are, I'll say, manufactured and maintained to a very high degree of quality. There are specifications that are used for the design and fabrication of those containers. There are specifications that we have to follow with regard to the handling of the components and replacement of components. There are annual inspections that are completed for each of those packages, where we take them out of service for roughly a month at a time, where we go through that maintenance inspection process. And then every 5 years, there's an even more robust inspection on those packages as well. And so all of that is laid out in the paperwork that is provided and approved by the NRC to ensure that the integrity of those containers is going to be maintained during shipping in the event of an accident.
Okay. So all right, so a couple other questions we had, in particular for Sean. Sean, can you talk a little bit about, one of the questions had to do with creating new, improving the airflow through the shafts. The question was, have you looked into electric vehicles or other similar mechanisms that might improve air quality below grade?
No, thank you. Yes, we actually, and I don't know if this is known to, thank you, a lot of people, but we have quite a bit of electric equipment in the underground already. Like our mining equipment, it's called a continuous miner. That's a large piece of electric equipment. We have a number of forklifts that are electric. We also have like one load and haul dump truck. It kind of looks like a front end loader would on the surface. We called it a load haul dump truck. That is electric as well. And we are continuing to look at more electric equipment. In fact, we've ordered a number of additional pieces of the electric equipment, if I can speak, to replace some of our diesel equipment moving forward. And so that is absolutely something we look forward to, trying to improve the air quality in the underground every chance we can. That will help quite a bit, as will the increase in the airflow in the underground. That'll be another significant improvement with the air quality.
size possibility.
Okay, thank you. So I guess the second question, Sean, follow up is like, can you speak a little bit to the employee training program for, and I know you can't go into specifics for each type of position, but what you do as an organization to make sure folks are prepared to do their job and know what's required and what they're looking for safety, for regulatory means, for things of that nature, just kind of broadly. And then we can follow up with maybe a better written answer. Not that your answer won't be good. But.
Oh, thank you. And that's a good question. And it is highly dependent upon, obviously, the type of work that the individuals do. As an example, we have our RAD control individuals who go through a very rigorous program where they have to demonstrate comprehensive knowledge with their processes before they're able to get out there and work. They're in a trainee stage for a considerable period of time. We have a lot of processes that require actually multiple years of training before they're able to be fully qualified. We have our facility shift managers who oversee the majority of the functions on the facility. That is typically a 2-year qualification where people finally go through, at the very end, they have to go through an oral board and written exam to ensure that they are qualified. And if they do not pass, they either have an opportunity to go into a different job or continue training for a period of time. But we don't allow people to move into those fully qualified individuals' positions, whether it be for our RADCon, our waste handling, our facility shift managers, until they have completed all of the training. And it usually includes an oral board and testing. Additionally, all of them have to be educated and trained regarding the permit, the hazardous waste facility permit, to make sure that we stay in compliance with the permit in every activity that we do. As an example, are the firefighters who we have on site. One of their jobs is to ensure that they go around and make that all the fire extinguishers are in compliance with our permit and our hazardous waste facility permit, because it has that level of detail in it. So they have to be educated to a very deep extent of everything that is in the permit so that we can remain in compliance with it.
Okay, so we are at our time where we need to move over to the one-on-ones, and then we're going to start that process. But before we do, Reinhard will give you a chance to make a closing statement, and kind of as a lead into that, one of the questions that just popped in: is it possible to do a tour of WIPP if somebody wanted to go and see it? So I'll let you speak to that, and then your closing statement, and then we'll prepare to move over to the second part of the meeting.
Right. So yes, it is possible to get a tour of WIPP. You can just talk with one of our public relations folks. Tim, Kush, Bobby are here. Just go ahead and grab them at a break, and get your contact information, and we'll coordinate a tour. Also, I know there was a couple questions that were, I guess, clarifying questions. I'll start with the drilling and fracking question. I apologize for misunderstanding the fine point on your question. So we are located on 16 square miles. Okay, there is no drilling allowed, including angle drilling. So all of that is off to the side. Now, when we take a look at, I'll say, a 10,000-year horizon, okay, so what happens in 2,000 years where people say, hey, we want to drill over in this area? The regulations that are associated with WIPP require that we have institutional controls that will get put in place when the repository closes. That is something that we'll have to get final approval on from the US EPA so that we're able to provide the correct type of communication techniques for future populations in the area. Additionally, the performance assessment that's done that looks at that 10,000-year horizon, which is what the regulatory framework is that we have to abide by, does consider penetration of the repository in by people drilling or so forth, and we have to show that there's no migration of contaminants as a result of that. And so that is all factored into it, including if conditions change or there's an increase in water in the underground because there's been a change in the water table or so forth. And so we spend a lot of time evaluating, as part of our transport models, how does plutonium dissolve in the brackish water? What does that mean for migration out of the footprint? And all of that is kind of laid out in the compliance recertification applications that we submit and reviewed by the US EPA. With the question regarding expansion in air quotes, I think your question is, how does the public have a chance to weigh in on additional panels beyond panels 11 and 12? And as was discussed in the presentation, we will be going through a NEPA process, and the first step of that process will be to issue a notice of intent. What follows that notice of intent is several scoping meetings. So those will be public meetings. I'll say they'll be in the more traditional format where there will be an opportunity for people to speak and not just ask questions. And all of that will be factored into the next step of the process, which would be a supplemental environmental impact statement. Those are typically estimated to take, they tell me 18 months. My experience is it takes 2 to 2.5 years to go through that process before the department is in a position to make a determination consistent with that particular regulatory framework. Now, certainly there are other aspects where we would have to get approval from New Mexico for additional panels as part of our permitting process, as well as with the US EPA. Adding additional panels to the footprint, even though the amount of waste that would be disposed doesn't change. It's just a reconfiguration of how that waste is distributed, and therefore we have to submit a plant change request to the US EPA that they will then evaluate. There'll be some of the calculations I talked about in the previous answer. That information will be submitted to them as part of our performance assessment to demonstrate continued compliance with regulatory requirements if we are interested in going beyond panels 12. Okay, so I hope that addressed the point I think you were trying to get across. So I do want to iterate, I know there's a number of questions that have been received. We will go through the process of reviewing those questions and ensuring that responses are posted online. This is something we've done at the last several meetings that we've had of this type, and so that we have a chance to get specific responses and questions out and make sure everybody is aware of what that is. That information can be found at the WIPP website. I do very much appreciate you attending. I'm very interested in some of the one-on-ones that we'll have here in a few minutes. I look forward to the chance to get into some more detailed discussions and understand the concerns and perspectives. Thank you.
Hey, thank you guys so much for being here. Thank you so much for being here tonight, and we appreciate this. And what we'll do is we're going to move forward into our one-on-ones. So if we can allow Reinhard and Sean to slide over into, if you can allow Reinhard and Sean to slide over to your tables in the next room, go ahead and let you get seated. We'll move that direction and invite you guys to come sit and speak with them and ask your questions and do follow-up discussions with them. We appreciate your time. Thank you.